Hi everyone. Today I will be presenting the SQL Learning Assistant, an AI-powered system that converts a natural language question into SQL queries. So the user input would be the natural language, a simple explanation, and the output would be the respective SQL query. Let's go for the problem statements. So learning SQL is challenging for beginners, when the syntax is strict and the translation, business questions or database queries requires understanding of the tables, relationships, schemas, and everything. So when we give this same to the ChatGPT, it ask you to have the exact schema relationship and everything. But let's say like if we don't have anything, and it will be very difficult to get the actual query, especially for the beginners or the person who is giving you the knowledge transfer. So that's why this project mainly focus on domain specific and schema specific natural language to the text SQL conversion. Let's go ahead with explaining you the architecture. So the architecture is when a user enters a question, it goes into the RAG retriever, which finds a similar examples from the knowledge base. These examples are passed to the prompt builder, which constructs structured prompt with the context and instructions. The fine-tuned model then generate the initial SQL query and it give the best one. And the final Gemini API enhances the query by checking any errors and optimizing if it's needed and giving you the natural language NLP kind of explanation. So only for that I'm using the Gemini. So all the SQL queries which are obtained is through the RAG, and the uh, pipeline is the SQL Learning Assistant is like where the a RAG we built on the knowledge base of over like 80,000 SQL questions. So it has a data set where the one column is the simple query, not simple query, and the other column would be the explanation of that query. So we use that to get the actual query, and we reverse engineer that so that we can get the vice versa of it. The second would be the Retrieval-Augmented Generation, which is our RAG. We built 80,000 SQL questions answer pairs in the ChromaDB. When a user asks the questions, the system retrieves the similar examples. Second, when the fine tuning, we build a TinyLlama 1.1 billion parameter model using LoRA for parameter efficient training. This makes the model specialized for SQL generation. Third, the prompt engineering. We use a context management, query intent analysis, and the edge case handling to construct optimal prompts. Fourth, we get the enhanced output using the Gemini. So that's what I have mentioned. So these are the tools which we got it. And let's go ahead and can give a short or quick demo of how it does. So this is the landing page which I hosted in the GitHub pages, where it has all the details regarding the project and it has the key features, what kind of pipeline architecture which we used, and what are the tech stacks. So as you can see, like these are the tech stacks, and we have the specific documentation as well. So when we click the live demo of this, we go to the page. This is done using the Streamlit, and it is hosted in the Hugging Space Spaces website, Spaces website, where like it has a good RAM and as well. So I hosted it here. So we can see this is the application, and there are examples which we can provide, and also you can type it out if you want. Let's say right now I can go for the example which I already have, which is like a calculate average salary by department. So if we ask this a question, and if we run it, so it will go to the pipeline based on this, which is the synthetic data will be tend to a fine-tuned model. The user asks the questions, right? And it goes to all these things which I mentioned before. And it has the like a final output where all these things will be structured perfectly, and we can use that and to get any queries in the actual database. So this SQL format is basing on the raw SQL format, which is like it is not specific to any particular SQLs. So as you can see, the generation is complete and gives the actual query, which is like select department average salary, salary, and from employee by group by department. So it gives everything, and it also gives an explanation. This SQL query looks as an employee table. So as you can see, it mentions perfectly fine. You can see the pipeline details as well here in the RAG. So since like we have mentioned the parameter as three examples to get it, so it got three examples. So and gives you the best score as well, which is like a 0.48, 0.47, and it shows what kind of SQL it got and from with what it took the entire prompt. Yeah, so as you can see, like it is converted into a prompt, and this prompt is fine-tuned with the TinyLlama model, and this gives the final output of it. And then we use Gemini to enhance a SQL and gives you the explanation for it. So as you can see, like this is working pretty much fine, and I can give you the results as well. So as you can see, the results are this. So we evaluated the like fine-tune model on like a few different types of samples using four different metrics, like so which are keyword accuracy. Model correctly identifies the operations like select, where, and group by. Structure similarity, token accuracy, and we give the index and a diversity score as well. So for the structure similarity, we have like a 91. As you can see, like I have a 91 percent showing model generates queries with the correct clause sentence, and we have a token accuracy of 47.21, which measures the word overlap and accounts for the variations in table and column names. Well, we also have like a synthetic database which we created in order to fine tune the model pretty much more. Where we expand the original samples like 50,000 samples to 142K samples, which is like a 2.72 times the increase in the maintaining the diversity score. Like this one's we expanded the diversity score is around 0.28, and like to finally summarize the future improvement ethics, and we have the privacy safety, and we have everything, so that like all the data should be anonymized, and we need to have everything in a proper way. So I had everything in place when we try to get the synthetic data, so that like none of the extra arguments is not passed on to the cloud or anywhere as well, because since like we are going specifically for the domain specific. So these are the web publication project and the repository. So you can go anytime there and you can try it yourself, and let's say like if that one works or not. So like the challenges we overcome include like the API rate limit to a fallback system. Like there are two different models and three different types of API keys which I got it. Since like a Gemini is free, I took that. You can also use the paid ones which are ChatGPT, Cloud, and everything. The project source code, documentation, and the live demo are all available in the link shown on the screen. So you can do anything more on that. So thank you for watching.